All right, guys, let's try question number 6 and question number 7 from the homework. And these two questions, they're essentially the same. And so let's take a look at question number 6 and let's do that one. It says there's a photon that's initially, or an electron in a hydrogen atom is initially in a quantum state n equals 2. It says it absorbs a photon. What does that mean? If it absorbs a photon, then that means that the energy goes up. And so that that means we're gonna solve for n equals x, this quantum number that's greater than 2. We know that it's bigger because again it absorbed the photon. All right, so it says that the wavelength of that absorption, or the photon that it absorbed, was 656.3 nanometers, and so we would want to use the Rydberg formula in order to sort that out. That's 1 over lambda, 1 over the wavelength, equals the Rydberg constant times the quantity 1 over NA squared minus 1 over NB squared. And remember, the big deal here is that NB always is greater than NA. And so that helps you set up the problem correctly. And then don't forget that your units have to match. So you have to convert your units for your wavelength in order to solve the problem correctly. So in order to set it up, I would do that conversion, 6.563 times 10 to the negative 7th meters. That equals 1.097 times 10 to the 7th meters over 1 over 2 squared, since I know that this value is the bigger value, and that's where it belongs. And so the rest is the work that I need to do in the problem. And so let's see how I might do that. I think I would multiply both sides by the denominator on the right. So I think I'll multiply both sides by this value. So I'm going to take 1.097 times 10 to the 7th, multiply it by 6.563 times 10 to the negative 7th, and I get a value of 1 equals 7.1996 times 1 over 2 squared minus 1 over x squared. Keep around those digits for the moment. And so let's simplify this. This is 1 over 2 squared, so that's 1 over 4 minus 1 over x squared. Then I think I can distribute the 7 through, so if I divide by 4, I get 1 equals 1.7999 minus 7.1996 over x squared. Okay, so I can do some more rearranging. Let's see, I need to get the x squared by itself. And so that's, I'm going to add that term to both sides. So I get 7.1669 over x squared plus 1 equals 1.7999. Okay, so let's deal with that 1. Go ahead and subtract it from both sides. So 7.1996. Let's see, 7.1996, good, over x squared equals that minus 1, so 0.7999. Now I need to get x squared by itself, so it looks like divide by the 7 on both, 7.1996 on both sides. So what I end up with is 1 over x squared equals 0.1111. Okay, so let's deal with that. Let's get the inverse of both sides so that I can get x squared equals the inverse. And so I'll take the inverse of 0.1111. And I get 9.000. So x looks like it equals 3. So there you have it.